Mars wasn't always a red, dusty desert. In fact, the planet we now see as a barren wasteland was once a vibrant world, teeming with potential. Billions of years ago, it might have looked a lot like Earth, with blue oceans and rivers flowing across its surface. Imagine vast bodies of water, perhaps even teeming with microbial life, shaping the Martian landscape in ways we can only dream of today. There's evidence that Mars had a thicker atmosphere back then, which kept the planet warm enough for liquid water. This atmosphere, rich in carbon dioxide, created a greenhouse effect, trapping heat and allowing water to remain in its liquid state. But over time, Mars lost most of its atmosphere. This gradual loss was a slow and relentless process, stripping away the very elements that made the planet hospitable. This transformation turned Mars into the cold, dry planet we see today. The once blue planet with its potential for life became a desolate and inhospitable world. Scientists believe this drastic change was caused by the weakening of Mars's magnetic field. Without a strong magnetic field, Mars was left vulnerable to the harsh realities of space. You see, Earth has a strong magnetic field that acts as a shield, protecting our atmosphere from the constant bombardment of solar wind, which is a stream of charged particles from the sun. This magnetic field is crucial for maintaining the delicate balance that allows life to thrive on our planet. Without a strong magnetic field, the solar wind stripped away most of Mars's atmosphere, leaving behind the thin, unbreathable air it has now. This relentless assault by solar particles eroded the Martian atmosphere, making it impossible for liquid water to exist on the surface. This loss of atmosphere is a major hurdle in our quest to make Mars habitable for humans. The thin air and lack of protection from solar radiation pose significant challenges for any potential colonization efforts. The question is, can we reverse this process? Can we find a way to restore Mars's atmosphere and make it a place where humans can live and thrive? Can we use technology to terraform Mars, making it more like Earth? This concept, known as terraforming, involves altering the Martian environment to make it more suitable for human habitation. It's a monumental task that would require advanced technology and a deep understanding of planetary science. The answer is complicated, but exploring the possibilities can teach us a lot about planets, technology, and the future of humanity in space. As we push the boundaries of what is possible, we not only learn more about Mars, but also about our own planet and the delicate balance that sustains life here. The journey to make Mars habitable is as much about understanding our place in the universe as it is about the red planet itself. Terraforming Mars is a monumental task. We're talking about changing an entire planet's environment. The two biggest challenges are the planet's thin atmosphere and its cold temperatures. Mars's atmosphere is about 100 times thinner than Earth's, and it's mostly carbon dioxide, which humans can't breathe. The average temperature on Mars is a frigid -63 degrees Celsius, which is far too cold for most Earth life. To make Mars habitable, we'd need to raise the atmospheric pressure, change its composition to include breathable oxygen, and warm the planet significantly. These are huge engineering challenges, but there are some intriguing ideas on the table. One of the most talked about ideas for warming Mars is to create a greenhouse effect. This concept involves trapping heat within the Martian atmosphere, much like how a greenhouse works on Earth. By increasing the amount of heat retained, we could potentially make Mars more hospitable for future human colonization. On Earth, greenhouse gases like carbon dioxide trap heat from the sun, keeping our planet warm. These gases form a blanket around the Earth, preventing heat from escaping back into space. This natural process is crucial for maintaining temperatures that support life. Mars has some carbon dioxide frozen in its polar ice caps and trapped in its soil. This carbon dioxide is currently in a solid state due to the extremely low temperatures on Mars. If we could find a way to release this trapped gas, it could play a significant role in warming the planet. If we could release this carbon dioxide, it could potentially thicken the atmosphere and trap more heat, leading to a warmer Mars. This process would involve heating the polar ice caps or the soil to release the gas, which would then contribute to a greenhouse effect. Some scientists have proposed using giant mirrors in space to reflect more sunlight onto the Martian surface. These mirrors would be positioned to direct additional sunlight to specific areas, increasing the overall temperature. This method could be combined with other techniques to maximize the warming effect. Others have suggested darkening the surface of Mars by sprinkling it with dark dust or even growing dark plants. Darker surfaces absorb more sunlight, which would help to increase the temperature. This approach could also help to reduce the amount of sunlight reflected back into space. This would decrease the amount of sunlight reflected back into space and increase the amount absorbed, leading to warming. By combining these various methods, we could potentially create a more Earth-like environment on Mars, making it a viable option for future human habitation. The challenge lies in the scale and feasibility of these projects, but the potential rewards are immense. Warming Mars is only half the battle. We'd also need to create a breathable atmosphere. One idea is to use machines to split carbon dioxide molecules in the Martian atmosphere into carbon and oxygen. This process, called electrolysis, would require a lot of energy, but it could provide a source of breathable oxygen for future Martian colonists. Another idea is to use genetically engineered microorganisms. These tiny life forms could convert carbon dioxide into oxygen through photosynthesis, just like plants do on Earth. This is a slower process, but it could be a more sustainable way to create a breathable atmosphere in the long run. Section 5. Tiny helpers, microorganisms on Mars. Microorganisms, despite their size, might be our best bet for terraforming Mars. These little guys are incredibly adaptable and can survive in extreme environments. Scientists are already studying extremophiles, which are organisms that thrive in harsh conditions like those found on Earth's deep ocean floor or in volcanic hot springs. These extremophiles could hold the key to engineering organisms capable of surviving and thriving on Mars. Imagine microorganisms specifically engineered to consume carbon dioxide and release oxygen into the Martian atmosphere. These tiny pioneers could pave the way for a breathable atmosphere, making Mars more hospitable for future human explorers. Section 6. The magnetic field dilemma. Remember Mars' weak magnetic field, the one that allowed the solar wind to strip away its atmosphere? That's a major problem we need to address if we want to terraform the planet. Without a magnetic field, any new atmosphere we create on Mars could suffer the same fate as the old one. Some scientists have proposed creating an artificial magnetic field for Mars. This sounds like something straight out of science fiction, but it's not entirely impossible. One idea involves building a large magnetic dipole at a specific point between Mars and the Sun. This dipole would generate a magnetic field that could deflect the solar wind and protect Mars's atmosphere. However, the technology required for such a feat is beyond our current capabilities. The concept of creating an artificial magnetic field isn't new. Scientists have been exploring this idea for decades, drawing inspiration from both natural phenomena and science fiction. Mars once had a thicker atmosphere and liquid water on its surface, suggesting that it might have had a stronger magnetic field in the past. Understanding the history of Mars's magnetic field could provide crucial insights into how we might recreate it. Advanced simulations and models are being developed to test the feasibility of various methods to generate a magnetic field. Collaboration between international space agencies and private companies is essential to tackle this monumental challenge. If successful, creating a stable magnetic field could be a game changer for Mars colonization, making it a more hospitable place for future generations. The dream of terraforming Mars is filled with challenges, but with innovation and determination, it might one day become a reality. Imagine a Mars with blue skies, flowing rivers, and thriving ecosystems. It all starts with solving the magnetic field dilemma. The journey is long and arduous, but the potential rewards are beyond imagination. The magnetic field dilemma is just one of many hurdles, but it's a crucial step towards making Mars a second home for humanity. Section 7. Is terraforming possible with today's tech? The short answer is no. While we have some fascinating ideas and theories, we don't yet possess the technology to terraform Mars on a planetary scale. The challenges are simply too immense. We're talking about altering the environment of an entire planet, which requires vast amounts of energy, resources, and time. However, that doesn't mean terraforming is impossible. Technological advancements are happening all the time. What seems impossible today might become achievable in the future. For now, our focus is on smaller-scale missions to Mars, like sending rovers and eventually humans to explore the planet and learn more about its history and potential. Section 8. A future among the stars. Even if we never fully terraform Mars, the research and development that go into exploring these possibilities will undoubtedly lead to new technologies and innovations that benefit humanity here on Earth. The quest to make Mars habitable pushes the boundaries of our understanding of planets, climate, and life itself. Imagine developing advanced life support systems for Martian colonists that could also be used to create sustainable habitats in extreme environments on Earth. Or imagine developing new energy sources for terraforming that could revolutionize how we power our cities. The possibilities are endless. Section 9. The final frontier awaits. The idea of terraforming Mars captures our imaginations. It speaks to our innate desire to explore, to push the boundaries of what's possible, and to find new homes for humanity among the stars. While we may not be terraforming Mars tomorrow, the very act of dreaming about it, of researching it, and of developing new technologies to make it possible, is a testament to the boundless potential of the human spirit. The final frontier awaits, and it's up to us to decide how we'll reach for it.